We're going to go over some multiple choice questions on vectors. This file is on the M drive as a PDF file in our course folder, and it is called Vector Clicker Questions. So I'm going to give you a little explanation for some of the problems, then I want you to pause the video until you come up with your own answer, and then you can resume the video to see if you are correct. So we have two vectors here. We have vector A and B. The magnitude of the vector is its length, and then the vector, to be a vector, has to have direction as well, so you can see what direction the vectors are pointing in. You can slide the vectors around, and as long as they have the same length and are pointing in the same direction, it's still the same vector. And in our first example problem here, we want to add 2a and, well, you can say 2a minus b, or you can say 2a plus minus b. So if I multiply vector a by 2, its length is twice as long. So I'm going to make this bigger when I draw it, but I'll keep the scale the same. Okay, so let's say this vector is a. Then 2a would be twice as long. So this is 2a. And vector b, you can just say you multiply it by -1. So b and a should have the same length. If this is b, negative b is just pointing in the opposite direction. Now, to add vectors together, so I'm going to add 2a and negative b together. Well, you're going to add them together first. You can place them tip to tail, and it doesn't matter what order you add them in, you still get the same resultant vector. So place them tip to tail, and the resultant vector starts where the first vector starts and ends where the last vector ends. Okay, so you can pause the video now and do 2a plus negative b. When you pick an answer from the list here, then you can resume the video and see how you did. Okay, so for 2a minus b, I take 2a, I can slide it around as long as it has the same length and is pointing in the same direction, it's still the same vector. Then I add minus b to that. Minus b looks like this. And the resultant vector starts where the first vector starts and ends where the second vector ends. So this is 2a minus b. And this looks closest to 5. So 5 would be the correct answer there. Okay, now we're going to go on to the next question. For this question, we want to add a and b and c. So we have 3 vectors now. You can place them all tip to tail, then draw the resultant vector, and when you've done that, I think there's only 5 options there. Yeah, so when you've done that, you can resume the video. Okay, so we want to add a and b and c. A and b have the same length. This is a, this is b, c is twice as long. There's c. So my resultant vector would be, that'd be number 1. This is question 3 from Vector Clicker Questions. The magnitude of vector A, that's its length, is 3 units. The magnitude of vector B is 4 units. What is the largest possible value that you can have for the resultant vector A plus B? You can think about it, pause the video until you have your answer, and then play it when you are ready to move on. So if you add A and B together, to get the largest possible value, you would want them to be pointing in the same direction. And if they are pointing in the same direction, you would get 7. So 7 is the correct answer here. For question number 4, what is the smallest possible value that you can get? So there are the choices. Pick one, pause the video until you do, and then resume. So the smallest possible vector, that would be when A and B are pointing in opposite directions, and that would be 1. So that's the correct answer. For question number 4, if A plus B, if you add them together and take the magnitude, and that is equal to the magnitude of A plus the magnitude of B, what is true about A and B? Are they parallel and in the same direction, parallel and in opposite directions, or are they perpendicular? A and B must be parallel and in the same direction if the magnitude of A plus B is equal to the magnitude of A plus the magnitude of B. In our next question, if the magnitude of A plus B is equal to 0, which of the following must be true? Are A and B parallel and in the same direction? Are they parallel in opposite directions? Are A and B perpendicular? Is the magnitude of A equal to the magnitude of B? It could be that none of the above are true. It could be that only one of the above is true, and it could be that 2 of the above are true. So pick which ones are true, and then continue. Okay, so A and B must be parallel and in opposite directions, and also the magnitude of A has to equal the magnitude of B, so that would be number 6, B and D. For our next question, we're going to talk about vector components. So let's say I have a coordinate system, and this is the x direction, this is the y direction, and then I have a vector like this. If I break this vector down into components, I have the x component and the y component. When I add them together, I get the original vector. The x component's going in the x direction. The y component's going in the y direction. So let's call this vector A. Then this is the x component, and this is the y component. So you take your vector, you make a right triangle with it, and if we use this angle here, the x component is the cosine component of the vector, the y component is the sine component of the vector. Now for this question, we want to know, can a component of a vector always be greater than the magnitude of the vector? Is it sometimes greater than the magnitude of the vector? Is it never greater than the magnitude of the vector? So you can pause the video and think about it, and then come back when you're ready to move on. So a component of the vector can never be greater than the magnitude of the vector. If we have a vector and it's just going in the x direction, so if you have a vector like this, then the x component of the vector would be equal to the magnitude of the vector, but a component of the vector can never be greater than the magnitude of the vector. And from the relationship that we have with Pythagorean's theorem, we can say this ax plus ay squared. So if ay is equal to 0, like we have here, then the magnitude of the vector is equal to ax, but you can never have ax being greater than the magnitude of the vector. In this question, if one component of a vector is negative, then the vector cannot, 1, have another component which is negative, 2, have more than 2 dimensions, or 3, be 0. So you can think about the answer to this, and you may want to consider the Pythagorean theorem that we looked at in the previous question in order to answer this one here. Okay, so if one component of a vector is negative, the vector can certainly have another component which is negative. That would just look like this, using our previous coordinate system. If this is x and this is y, this would be a vector that has 2 negative components. The vector can't have more than 2 dimensions, so you can have a third dimension. I can't draw it here, but you can have a vector with 3 dimensions and one of the components can be negative. But the vector cannot be 0. The magnitude of the vector cannot be 0, because if you go back to the Pythagorean theorem here, if ax is, it doesn't matter if ax is positive or negative, but if ax is not 0, there's no way to choose ay so that the magnitude is 0. So if ax is not 0, positive, that would be like what we have here. And if the y component is 0, this vector still has a non-zero length. Okay, so for this question, the vector cannot have a magnitude of 0. If you add a and b together and you get a magnitude of 0 for the resultant vector, then the components of a and b must be 1, positive, 2, negative, 3, 0, 4, equal, or 5 of opposite sign. So think about it and then resume the video. So if you have a pointing like this, and you're going to add a to b and get 0, then b must be pointing in the opposite direction and have the same length. So the vectors have to have the same magnitude but be pointing in opposite directions. If you look at the components of b, here's the y component, here's the x component. If you look at the components of a, here's the y component, here's the x component. If they're going to add to 0, the x components must have the same magnitude but be pointing in the opposite direction. The y components must have the same magnitude, or you could say same absolute value, pointing in the opposite direction. So the answer here would be of opposite sign. So the sign of the y component, if this is the positive y direction, and this is the positive x direction, then this would be positive for the y component, this would be negative for the y component, this would be positive for the x component, this would be negative for the x component. So they would have to have the same absolute value but opposite sign in order to add up to 0. Okay, and this question, we're going to talk more about this in our next set of multiple choice questions. Here, this notation, where the x and y components, you have I hat here, which is for the x component, j hat here, which is for the y component. So this tells you you have 3 in the x direction and 6 in the j direction. So this should be twice as long as what we have here. If you add them together, that gives you A. B is going 6 in the y direction, so that's like this. C is going negative 3 in the x direction, or you could say 3 in the negative x direction. Okay, and again, we'll talk about this more in our next video. Which of these vectors has a component that's equal to the magnitude of the vector? Well, using the Pythagorean theorem, okay, here you get the magnitude by doing 3 squared plus 6 squared and then taking the square root. That would not be equal to 3, it would not be equal to 6, so it can't be A. For B, you do 0 squared for the x component plus 6 squared for the y component, take the square root, that gives you 6. So it is B. It's not C, because for C you would do negative 3 squared plus 0 squared and take the square root, which would give you 3. So the magnitude of vector C is 3, but the component, the x component, is negative 3. Okay, so that concludes this series of multiple choice questions. And then we're going to look next at another series of multiple choice questions.